For question number three, these are theoretical questions that are, I guess, part of problem number 0. And I have some of the answers written up already. First one, explain the difference between descriptive and inferential statistics. Descriptive statistics summarizes or describes characteristics of known population or data. Inferential uses a sample to make inferences or generalizations about a population. So that's when we started to study chapter 4 and 5, that began the foundation for our inferential statistics study. And then when we finally did chapter 6, that began our actual estimating and making inferences part. So, and from here on out, 7, 8, 9, and 10, we'll be doing inferential statistics. Part B, would manufacturer, why would business be interested in constructing confidence interval for the variance or standard deviation? And would they want a large or small variance? Basically, a quality control. Manufacturers and business would be interested in small variances, a consistent product. So they would be interested in it to make sure they control their consistency of their products. An example would be like a potato chip company or something like that. They often do quality control assessments by finding the standard deviation or variances of the amount of salt that they have in bags. So they pick random bags out of the control line and test the amount of salt that they have in the chips or in the bags to make sure that it's consistent, so it doesn't get too salty or too bland. The part C, determine left right tail, explain how you shade a critical region and give examples, which includes claim, hypothesis, and a diagram. So for let's assume that we're working with proportions. This is section 7.3. If you have a claim or an alternative hypothesis, that's H1, that looks like your proportion is not equal to some number, I'll just put 0.5, it could be anything, then in your normal distribution you would be looking at a critical region that's spread out into two tails. So this is an example of a two-tail test. And just to change things up a little bit, and let's do another example where your alternative hypothesis is dealing with the mean, mu. If it's less than some number, I don't know, 430, just an example, then whether you're dealing with a t or a z distribution, your test is going to be on the left side. So this is a one-tail. It's a one-tail test. More specifically, it's a left-tail test. And then so an example of a right-tail test is that if your alternative hypothesis and is greater than 5, I don't know, just making it up. In this case, you would be using a chi-square distribution, and then you would shade in only the right side. And so in this case, it's a right tail test. Just want to point out that when you're doing this, when you're actually doing the test here, we're looking at the alternative hypothesis to give us a direction of whether it's a two-tail or a right tail. It actually doesn't say anything about the claim. Your claim can either be the alternative hypothesis or the null hypothesis. It depends on whether your claim contains a condition of equality. So if any of these were your claim, none of these contain a condition of equality, and so they would always fall in the alternative hypothesis. And that's what directs your right tail or left tail or one tail or two tail. The last question, part D, central limit theorem, I would just ask you to see the book. I'm not going to fill that in. But the book has the information. The thing about the central limit theorem is that I'm not going to stress it too much, the details of it, but just so you know that we're actually using the results of the central limit theorem to apply some of the theories that we've already began to use and will be using for the rest of the semester. So that's problem number 3.